Hi guys, so today we'll be solving Leetcode weekly contest 364 fourth problem, that is count valid paths in a tree. Pause the video, read the question, and then we will proceed. Okay. So what the question is saying that there will be an undirected tree, and the basic definition of the tree. Now we need to return the number of valid paths. And what is a valid path? A valid path is a path which contains exactly one prime number. So from all the paths starting from A and ending at B, there should be exactly one prime number. And it can be either A or B also. It doesn't mean that it have to be in between of A and B. Either A or either B can also be a prime number, or any node between A and B can be a prime number. And also A and B will always be distinct. It's not like that A and B can be equal. It cannot be equal. Okay. So cool. The question is straightforward. Let's go to the example ones. So let's say there is a tree given. Now what we need to do is we need to find all the pairs of nodes such that there is exactly one prime numbers between them. So let's say if I start with 3, from 3 I can go to 1. That is one valid pair, like 3 and 1. Can I go to 3 to 2? No, because there will be two prime numbers, 3 and 2. Similarly, for 1, I can't go to 3 because I have already counted. Okay, so I can go to 2. Yeah, I mean, they had this. There is one more condition mentioned that A, B, and B are the same path. That's why I am saying that we can't go from 1 to 3 because we have already counted 3 to 1. Now, for 1, we can go to 2. Yes, we can definitely go to 2. From 1, can we go to 4? Yes, we can go to 4 because overall the number of primes will be only 1 because 2 is the only prime. Can we go from 1 to 5? No, because there will be two primes again. So basically for 1, we can go to 2, there will be one path, and 1 to 4 there will be another path. So in total till now we have three paths. Similarly for 2, can we go to 1? No, because we have already taken the path 1 to 2. So we won't go towards 1. Can we go to 4? Yes. And here there will be only one path, 2 to 4, and there will be only one prime between 2 to 4, that is 2. So we'll add one more path, that is now the total path will become 4, and valid path basically. And 2 to 5 we can't take because there will be two primes. Okay, I hope the question would be clear. Now now how should we approach this question is very clear. How should we approach this? So one thing you can see, let's say this is a group. Okay, and or it's better, let's understand it this way. I'm saying that here are three students and here are two students. So, and one student can talk to any other student in other group. So what will happen? How many pairs will be there? 3 into 6. Okay. Now let's say if I am saying that, let's consider something like this, that there is three nodes, and somehow it connects to one node which is a prime, and this prime connects to two other nodes. Okay, what I'm saying, listen carefully. So I'm saying that there are basically three nodes. Consider this. There are three nodes on this end, A, B, C. This connects to indirectly only one prime, P, and this P is also connected to few other nodes. Okay. So, okay, sorry, there is one mistake. Sorry. Basically, these three will be in a single group. So basically, these three are single group. So I'll just give me a second. Yeah. So basically these three will be connected something like this. Okay. And now this is connected to a prime P, and this is connected to some other group. Let's say in this group we have two other nodes. So just similarly like the students example that we saw over here, for each node, for node over here, I have two possibilities. Either I can go from this P to this one, or I can go from this one. Like, let's number it to A, B, C, and then 1, 2. So I can go either from A to 1 because we need to include one prime number. That's why we can't go from A to B. So we can go from A to 1 or 2. Similarly for B, we can go to 1 or 2, or similarly for C, we can go 1 or 2. So in total, if we'll see how many paths we have, the number of nodes in this group multiplied by the number of nodes in this group. Okay, I hope this will be clear. Now, let's say if there were more groups, so there is one prime, there's a group with three nodes, this is the group with three nodes, this is the group with two nodes, and this is the group four node. So, how many valid paths can be there? And we know that there is no other prime in any of the group. There is no prime in this, no prime in this, no prime in this, no prime in this. So that means we can take any node from this group and can go to any other group. Okay. So how many valid paths will be there? There will be, like, if we consider this four can go to either to the group with two sides or three sides or three sides. So in total, how many nodes for like any node from node can go to how many total nodes? 2 plus 3 plus 3. So basically it will be 2 plus 3 plus 3. So it will be, you got it right, 32. Similarly for this 2 we can calculate this 2, what will be the number of nodes? This will be 4 multiplied by sorry 2 multiplied by 4 plus 3 plus 3, because for any node in this group 2 we can go to any other node in this fourth group or this group or this group. Okay, but one thing, so what will happen that we have already counted nodes from going from 4 to 2. Okay, and when we will be coming from 2 to 4, then also we are counting the same node. So what we will have to do, like whatever the sum, let's say this will be the current valid paths. Okay, so whatever the current valid paths, let's denote it as simply as cur. So whatever the value of cur is, that means we have counted each path twice, once coming from 2 to 4, similarly 4 to 2, similarly 2 to 3 and 3 to 2. So what we are doing is we are counting the same path twice. So the cur should be divided by, not cur, it should be cur. Cur should be divided by 2. So that will be our actual valid path. Now, that is one case when we are moving from one group to another group. Now, there is one more possibility. And what is that? Let's look at that. So, if we are at P and we can go from any of the node in this, or similarly, like from any node of this group, we can come to P. Similarly, for this group, similarly from like P, we can go to any node on this group or come back. But we know that we can count only once, so either we'll be counting going from P to this group or from this group to, from any node of this group to P. So let's keep it only once. So in total how many valid paths? Because our condition is still satisfied, if we'll take any path from any node in this group to this prime P, then number of primes will still be 1. So, and now, how many nodes are here? Here, two nodes. So, how many valid paths can be from this group, this P to this group? 2. Similarly, how many valid paths from P to this group? 4. So, in total, how many valid paths we'll have? Sum of all the groups. Sum of all the groups, that is 2 plus 4 plus 3 plus 3. Okay. I hope till here everything is clear. I'll just repeat once again what we have discussed. So I'm saying that if there is a valid number P, sorry, if there is a prime number P and we have four group attached to it, let's say four group attached to it, and we know the size of each group, and there is no other prime in this group. Okay, these are not primes, no primes. So what will be the total value? First of all, let's say cur is equals to 0. Then in cur what we can do, and we know that the total sum is 3 plus 3 plus 2 plus 4. Okay, 3 plus 3 plus 2 plus 4. How much it is? 12. So total sum is 12. Okay. Now, for this 4, we know that we have to exclude this, or like take the sum of this. Take the sum of these three nodes or three groups, and we can multiply it by this. So what we can have, that is total sum minus 4 multiplied by 4. Similarly, plus total sum minus 2 multiplied by 2 for this group. Similarly, for this group, these two groups, what we have, sum minus 3 multiplied by 3 plus sum minus 3 multiplied by 3. Okay, and also we know that we have repeated the paths, that is, for any valid path from 4 to 2 is also counted when we are taking 2 to 4. Okay, so for that we'll have to divide cur by 2. So we have divided cur by 2, and now we know that any path can also start end at this one or start from this one, we can say. So we have to count only once. Either we start from this or end at this, because both path will be same. So let's say if there is a path from P to any node in this group, that will be 4 total paths. Similarly, if we come to this group, there will be 2 total path valid paths, and similarly 3 and 3. So in total, what will be the valid paths? That will be total equal to the sum. So we can simply increase the cur by cur plus sum. Now, so here what we have, for any prime P and the groups, different groups attached to it, we have total valid paths. Okay. Now coming back to our question, in our question what was in our question what it is saying, the total valid paths. We know that if there is one prime and we know the size of each group it is attached with, then we can calculate the number of valid paths for that particular prime. Okay. Now we know that at max, yeah. uh, so for any prime, what is the required, what is the requirement we have right now? We have to calculate, what we have to calculate, the size of group, size of all the groups we have, it has been attached to. Okay. So and also we are saying that there will be no other primes. So let's say now how can we calculate it? Okay. So let's say if this is the prime P1, there are some nodes something like this. This is connected to prime P2. It can have different kind of or complex structure, we can say. Okay, let's say there is one more node and this is prime P2. Ignore this for the timing. So if we start a DFS traversal from here, okay, if we start a DFS traversal from here, and we'll keep count how many nodes are in this group until we found a prime number. So if we find a prime number, then we won't move in this direction. We will just return from here. Similarly, we won't move to other prime as well. So what will happen that we can have our count of this particular group, right? Now, how can we identify this group? We can give it some number. So let's say I given it the number 1. Similarly, if I have something like this, okay, and this is connected to some prime P3, okay, and this is connected to some prime P4, then what I can have from P1, this is not exactly, I mean, this can be represented directly from P1. So P1, what we can see that there is another group consisting of size 2 and another group consisting of size 3 connected to P1. But we know that if we'll number it, this is group 2 and this is group 3, then once we have calculated that the number of nodes in group 2 is 2, then we don't need to calculate it again. So whenever when we'll come to P3, we don't need to compute for this group number 2. Similarly, so what I am saying over here is, if we have the count of nodes in each group, then we don't have to calculate again and again. So we need to find the number of we need to find the number of nodes in each group, and that can be done in big O. And I hope this is clear. I'm repeating again. So what I'm saying is, if there is a prime number, okay, and there is another prime number, so if there is bunch of nodes connecting them, then if we calculate the number of nodes for that particular group for prime for P1, then the number of nodes will remain same for P3 as well. So if it is calculated once, we don't need to calculate it again and again. Now, what are the conditions for calculating this group? That all numbers should not be equal to, should not be, or any number should not be equal to prime. Okay, any number should not be equal to prime. All numbers should be composite. Okay. So what we can do is, we can start with any composite number, and then we can keep going till we find some prime number. If we find a prime number, we'll just simply return 0 from there. Else we will just return 1 plus whatever the rest of the subtree looks like. Okay. So, and also we'll have a group number saying that, okay, this is the group number for this particular group, and for each node in that particular group we will assign the group number. And at the end what we'll do, so once we have all the groups ready, so let's say this is group 1, group 2, group 3, something like that. Okay. Now what we'll do, we'll check the prime numbers. So if any number is prime, let's say 2 is prime, then we'll check what are the children, what are its children, and what is the group count, or basically group sizes of different groups. So let's say for G1 it has 2, then 3, then 4. Then again we know that now the question returns to our very first example, where we have this prime P1 and there is a group with size 2, there is group size 3 and group of size 4. Now we know how to calculate the valid path for this. Okay, so for all primes, what we can do is calculate the valid paths and we can just return the sum. Okay, now let's go through the code once. So let's say, let's how can we, so first of all we need to verify which number is prime or not. So what we can do is we can use Siva Piratonis. Sorry for pronunciation. Okay, so we can use C for calculating the primes. That can be done in n log n, log of log n. So that is one thing. Now we will create the tree or adjacency list. We created the adjacency list and I have made most of the things as global so that we don't have to pass in the DFS call. Okay, so we created this adjacency list and initially we have group number 1. So what I am doing is, if in this for DFS, in this DFS I am simply returning what will be the count, and in this DFS what I am doing is, if it is a prime or we have already visited, then we don't need to visit it again and we can simply return 0. Else whatever the node we are at can be numbered as the group number, and that number, that node can be counted once, and whatever the sum of come from its children, we can take that and we can finally return the sum. And once this sum, once the number of nodes, basically we find that in particular group, then what we can do is we can just store that in group count of group number, that okay, this is the group number and what the total number of nodes in that group is count. Okay, so we are storing that. Now we have final answer equals to 0, and then what we are doing, we are checking if it is a prime, then only, because our assumption was whole based on, we are taking that one's prime and rest another is composite groups. Okay, so what we are doing, that if it is prime, then what we needed, we already know that if it is a prime, if it is a prime, then we need to see what all groups are connected to it. So for that what we can do is we can simply run a loop on its child. So for auto child into adjacency of whatever the node it is right now, and we already know the group number of each node, we already know the group number of each node, that is stored in, that is stored in visited. Because if we'll see here in our DFS, what we have done is, whenever we are marking it visited, we are marking it with group number, and that's why we have started our group number with 1, so that later we can identify that node is belongs to which group, any particular node belongs to which group. So now for each child, first of all we are identifying which group it belongs to, and we have also stored the count for any particular group in group count. So in group count we are finding the number of nodes for that particular child, and we are inserting into v. Why we are doing that? Because we know that for, let's say there are 4 groups, 4 3 2 and one more 3. So for this 4 we have to calculate that what is the total sum. So basically total sum would be 4 plus 3 plus 3 plus 3, that is 12. Now for this 4 we'll have to calculate 4 multiplied by 12 minus 4. So for each node or for each group, basically for each group what we have to do is we have to find this value, that is group count multiplied by total sum of minus group count, that particular group. So for that we are storing each number into a vector v, and we are also calculating the total sum. Finally, that current valid paths for that particular prime I can be found at, we are simply multiplying the total sum minus that current group's count multiplied by that current group count. And finally we know that we have counted both numbers twice, or both valid paths twice. So like all the paths from here to here is counted once, and again here to here. So we are dividing that by 2. And also there was one more possibility, that all the paths start, or we can say end at p. So how many paths will be there? So total number of nodes in like the basically the sum of all the nodes in all the groups, count of sum, sorry, sum of counts. So that can be, represented as sum, because in sum we are just counting what is the total number of nodes in all the groups, and finally we can add that to our answer. So for all the primes between 2 to n, because we know that primes start from 2, so for all the primes between 2 to n we are calculating the valid paths, and finally we are returning it. Okay, I hope question would be simple, sorry, question you have understood the solution for this particular question. Let's try to submit this, and let me know if you guys have any doubt in the comment section. Okay, thank you guys, see you in the next video.